We're now doing problem 13, the last problem. The outer loop starts with I equals 2 and then it squares. So actually I is 2 and then 4 is 16, 256, and it goes up pretty fast. This is 4 trillion something after only 1, 2, 3, 4, 5, 6 steps. Now the inner loop starts at 1 and goes up to I, and it does so linearly. So that means that the amount of time it takes on the inner loop for each iteration is equal to the value of I for that particular outer iteration of the outer loop. Alright, so let's look at what that means. When I is 2, then j runs from 1, well, it's only 1, that's the only value. If I is 4, you get 1, 2, and 3. If I is 16, j could be 1 through 15. And similarly, if I is 256, it's 1 through 255. And of course, we could keep going, but then we're going to run out of board space. So let's see how many times the inner loop iterates. We'll call that capital T. And that, of course, depends on n. Well, if n is 2, the inner loop iterates only once, because I has to be 2. All right, now on the other hand, if n is 3 or 4, then we get 2 iterations of the outer loop, which means the inner loop iterates once for this and 3 times for that value of j here, j equal to 3 and 4. So if, on the other hand, n is more than 4 but less than or equal to 16, then the inner loop iterates an additional 15 times, so a total of 19. All right, now continuing, if j is between 1 and 255, that's 255 more iterations. Add that to 19, you get 274. And of course, we could keep going, but we'd, of course, run out of whatever. All right, now, one question is, how can we write big O and big omega of these things? Well, we can't write big theta of anything. But let's look at this. Let's divide this for each n, 2, 3, 4, on up. Let's write the value of t. N is 2, t is 1. For 3 and 4, it's 4. For 5 up to 16, it's 19. For 17 up to 256, it's 274. Then starting at 257, it's 65,972. Yeah, we're going to run out of board, of course. All right, now let's look at this. You notice that when n is just a little bit more than the break-off number, this number here is approximately the square of it. On the other hand, when it's the biggest number in that block, it's approximately the same. It's off slightly, but it's theta of the number. So what we can say is, this number, the time complexity, let's call that t, is no more than what? If n is 4, then you get these numbers, which the value could be approximately the square of 4. But that's as big as it can get. For values that are larger than that, this number t would be even smaller compared to n squared. Well, it'll still be the same, but remember n squared gets bigger. On the other hand, the largest number in there is approximately n squared. I'm sorry, it's approximately n. Omega of n there, you see? And so those are the best you can do. So these two answers should be given as the answer to problem 13.